Hi, my name's Stephen Touchton. I'm a student in Dr. Greco's 2212 Physics 2, Modern Physics 2 class. So I'm doing the extra credit video on baseball and physics. You can observe a lot by watching was the title of the physics colloquium lecture. It was by Alan M. Nathan, and he covered a couple of things, main things in his lecture: ball-back collision and the flight of the baseball. So first things first, I'll cover ball-back collision. So the first thing we'll talk about in terms of ball-back collision is the batted ball speed. The batted ball speed has to do with three main variables. You've got Q, which is the collision efficiency, the velocity of the pitch, and the velocity of the bat. Obviously, both of those things play into how fast the ball is going to be moving when it moves off of the bat. That's what the batted ball speed is. So looking at an example, a typical Q is about 0.2 for a baseball. The velocity of a pitch is about 85 miles an hour, and the velocity of the bat, just how fast the batter swinging the bat, is about 70 miles an hour. Plug those into the equation, and you get a batted ball speed of about 101 miles an hour. 101 miles an hour is about 400 feet in terms of how far the ball is going to move through the field. So the bat speed actually matters, as you can see in the equation, a lot more than what the pitch speed matters. It's about 6 times as much, in fact. So the bat speed correlates to about 6 feet for every mile an hour, and the ball speed correlates to about 1 foot for every mile an hour. One thing that's not really taken into consideration in this batted ball speed equation is the sweet spot of the baseball bat. So you can imagine, like with a tennis racket, there's a sweet spot the tennis ball has to hit that's going to make it bounce the best. Same thing with a baseball bat. There's a sweet spot along the bat that if the ball hits right on that sweet spot, it's going to go the furthest distance. If it hits right off of that sweet spot, there's going to be vibrations that go through the bat that are going to decrease the ball's really velocity and the distance that it can travel. So the second topic he talked about was the flight of the baseball. So we're going to break the flight of the baseball up into 2 parts: before it hits the bat and after it hits the bat. So before it hits the bat is all to do with the pitcher, and obviously the pitcher he wants none of this stuff to happen. He doesn't want the ball to make contact with the bat. So what he's going to do is throw lots of different types of pitches. There's curveballs, knuckleballs, fast pitches, slow pitches. One thing that's interesting, the knuckleball doesn't spin at all, so that's a really hard pitch to throw, and it's a really hard pitch to hit because you can't really determine the trajectory. It seems to kind of wobble around in space. And there's some cool videos on his website. I'll put that in the comments below to check out. So the spin of the baseball matters before, so the pitcher's spin of the baseball matters as to whether the batter's going to hit it or not. Afterwards is after it makes contact with the bat. What spin does it have after it leaves the bat itself? So actually Fox Sports South used a 5,000 frame per second camera to video the World Series in 2012, which is really cool. It's kind of new technology. You can get on his website and there's a really cool video of the bat actually breaking as the hitter hits the ball. And it hits the ball 3 different times. On that last one, it puts a pretty significant spin on the ball, which sort of might throw off shortstop and where he thinks the ball is going to go. So this is new technology that might be cool to assess the spin after it hits the bat. Another interesting video on his website is actually the ball leaving the batter's hands before it makes contact with the ball. So he swings, sort of lets go of the bat, and the bat hits the ball, almost like he's throwing the bat at the ball. And he found out that Alan M. Nathan found out that that doesn't have any effect on the trajectory of the ball as long as the bat's making contact with the ball. That's all that matters. So that about wraps up my discussion on Alan Nathan's talk. I thought it was really interesting. He taught me a lot of stuff that really I didn't know. You think that the ball just goes at the bat and he hits the ball and it goes as far as it goes. But Alan Nathan's put a lot of thought into all this, and it's interesting that all the spin matters before and after it hits the bat, the sweet spot of the bat, and all the way down to this batted ball speed equation. So interesting stuff. Hopefully you found it interesting too, and I'll see you all in class. Go Braves!